So it's called the Itsy Bitsy Spider. The words are on the board. So sing along. You have to stand up so people can see. It says, water vapor rises into the atmosphere, cools and condenses, forming droplets there. Down to the earth, the raindrops they do fall. Most is absorbed, but not this night for all. And that's our segue into water runoff, which is where does water run? Okay? So feel free to copy that. It's not the greatest, but it's something. So, what is water runoff? Crickets. I get crickets. Yes, ma'am.
It's like when it rains really hard, really fast, and the water runs down my street, and it's just like you can put it in your internet.
Exactly. It's kind of like a flume ride, isn't it? So, how do you calculate that? The amount of runoff.
How much water that is?
I mean, does it run off the same way in every area?
Okay, so what if it were like the parking lot? Would the runoff be fast or slow? Fast. Why would it be fast?
Empty parking lot or parking lot?
Flat parking lot. Flat parking lot. Fast or slow?
Depends on if it's flat or slow.
Okay, so the slope of the hill does matter, doesn't it? We really aren't going to talk about that today for our little deal, but you can certainly go really far with that in this lesson on your own. So what we need to do is we need to calculate the runoff. We have Farmer Jones and his barn. Okay? Because there is obviously nothing for this water to absorb into because the barn is in the way, we have to calculate the runoff. So we need the volume. We have to start with area. What is area? Length times width. And the length of Farmer Jones's barn is 20 feet. And let's go with the back table and maybe the front, maybe the back 3 tables on this side. I want you to calculate Farmer Jones's area on his barn. He is 10 by 20. Okay? These guys are here, these. I want you to calculate Charles Chemical Plant building foundation thing. They're 5 by 40. Okay? But I want you to predict, who do you think is going to have the biggest runoff? Farm Jones. Chemical plant.
50 by 40?
5 by 40. Okay. 5 feet wide, 40 feet long. What do you know? Just think. Which one do you think is going to have the most runoff? Predict. Don't calculate your French numbers yet. What do you think? How many people think Farmer Jones has the most runoff? Chemical plant has the most runoff.
Oh, you have to vote one way or the other. When you make a decision, no
You've already done the math in your head.
No
Okay.
standing on the fence. You got to pick something, one or the other.
Jones? Carl? Bunch of wishy-washy people. This is 5th and 6th grade. Not collegiate. I have my they know how to do it. Which do you guess? Which do you think they would guess? You would think that it would be Farmer Jones. Why? It looks bigger.
As a barn.
It's as big as a barn, exactly. So,
Yeah, it does. It does look that way. That's the other, she says too, because of the way the picture is, it makes Farmer Jones look like he's at the top of the hill. So it's also going to make a kid think that you're going to get more runoff because of the slant.
right. But if we're just looking at area alone, the postage stamp that it creates on the earth. Okay, so we crunch the numbers, and 10 times 20 is, everybody? 200. And then we get into label math, which is going to be square feet, right? Then we also have to figure out Carl's chemical plant at 5 times 40, which is 200. And so we crunched the numbers specifically so that they would be exactly the same, just because it's a mind game.
But you can see how easy it would be for this lesson to go from really lower level up to some really higher level.
Absolutely.
I kind of like controversy in my classroom. I kind of like to try to pit different groups against each other because you get more of that conversation between them and a little bit of competition and a little bit of arguing about, well, no, it's going to be this or it's going to be that, and that whole, the farm's on the slanted land. I just think you get much better ideas out of kids. And sometimes it doesn't matter whether they're right or they're wrong if you just get them thinking in a direction that you want them to go.
Also, I'm the outdoor science teacher, so very easily you could set up this outside and have the kids measure that for even your lower grades and have them, so it's a community, because I treat the community through fit, so they would have to be all involved. So.
I'll tell you, also your GT kids will look at that and they'll look at, oh, that roof is slanted, so there are a lot more water's going to run off that. And those roofs are flat, so they're going to hold water on there.
Right. And surely in the real world that is the right answer, but because we're looking at just the area of this postage stamp, we're just leveling that playing field.
But I do think it's good for kids to think of that. I mean,
yes.
if they're
Absolutely.
giving kids that using those higher order thinking skills, if they come up with that somewhere.
Can I ask a question?
Sure.
What would you do if you had a kid say, well, yeah, but Farmer Jones is an organic farm and the chemical plant, sorry.
With what we do, we've gone to a lot of just real inquiry based. So even just having these conversations allows us to give the kids those points to decide for themselves what they wanted to test. I could have a group that ended up testing, well, does the slant affect the amount of runoff? And some other group might be testing, does water runoff through affect how much the water is run off? Because that's just kind of the direction that we're going at our school. So all of these conversations are important to me because I'm trying to get to that.
How to think?
Yes, exactly.
She's a fabulous thinker creator. All right, so after that we need to then go on to volume, and just for the ease of easy math, we go with 1 inch of rain because every kid can multiply times 1. But it's really because of the label issue, you can't have inches per feet squared or whatever. So you have to convert the inch into 1/12 per foot. Okay? So that math, notice it's blank for you to figure out. Go ahead and pull out your phones and calculators. Feel free to do that because you would take your 200 times 1/12. Which is really divided by 12. So take 200 and divide by 12, which is, I heard it, 16.66.
16 2/3.
That's right.
And you say 6th graders know.
I wrote it.
They know some math.
16.66.
I always get that.
And that's going to be feet what?
Why are we doing this? This is science, not math.
Because it's volume.
She's got it. Somebody's saying it back here.
Say it louder. Cube, yes. So, it's feet cubed. Awesome. And then with our volume, we now get to calculate the weight of the rainwater. And this tidbit of information was given to us in the activity that rainwater weighs 62.5 pounds per cubic foot. So what do we need to do? What math do we need to do? Do we multiply? Do we divide? Do we subtract? We're going to multiply them. So 62.5 times 16.67 equals, crunch it.
What is this dirty water? Why does it have on the mud? Where should we have here? Isn't that more math?
Green
Hold on to that thought. We've got another.
What is it? What is it?
coming
Mary Pearl
up.
has it. Mary Pearl has it.
1,041, 8.7.
Yes! Give the girl a star. So, say that again, it's a big number.
1,041.875.
That's a lot.
Well, that's with the rounding.
Of course.
The point six.
Of course, that is the weight of the water carried by Mr. Jones's foundation with 1 inch of rainfall. That's if it all dumped right then, right there, boom, right? Cumulative. Then Carl, chemical plant has the same issue. So, again, we could take this way farther than what we can do in our 20-minute allotted time frame. Okay?
You can see how the math is very easily above 6th grade math. You can go above that all the way up to 12th grade.
Oh, absolutely.
Can we see that? I think we don't see that.
Our runoff now becomes an issue with we can't all live upstream, okay? Which is a huge Mississippi River thing, you know, from New Orleans to huge Minneapolis. So that gets into our next step.